Hello, welcome to Distinction Tuition Center. My name is Kakoma, and today we are going to learn about the trigonometric ratios under the special angles. So what are these special angles? These are special angles that are used to find the sides without using a calculator. And these special angles are 30 degrees angle, 45 degrees, and 60 degrees. So to start with, we are going to start with the 45 degrees triangle. So remember here we are still looking at the right angled triangle. So consider the diagram below here. Consider the diagram ABC with a 90 degrees angle there. So we are looking at a 45 degrees angle, which means this angle should be what? 45 degrees. So if this angle is 45 degrees, that means also the other angle there should be 45 degrees. So that when you add 45 plus 45 to give you 90, 90 plus 90, it's 180, which is a complete triangle. So if you have the same angles, that means also these sides are what? Are the same. And what type of a triangle is this? It is an isosceles triangle. So imagine here AB you have 1. That means even BC you are going to have 1. So what are you going to do for you to find the distance AC? So this is why you are going to use the Pythagoras theorem. And what does the Pythagoras theorem state? The Pythagoras theorem states that the longest distance, which is AC, squared, you square it, is equal to the short distance AB, you also square it, plus the other short distance, which is BC squared. From there, you have AB and you have BC. So it's now the time to find the AC squared. So what are you going to do? You have AC squared here is equal to, what is your AB? Your AB is what? Is 1. So you have 1 squared plus, what is your BC? Your BC is also 1 squared. So from here, you now multiply. This is same as 1 times 1 plus 1 times 1. So you're going to have AC squared is equal to 1 squared, it is 1, plus 1 squared, it is also 1. 1 raised to any power, the answer will still remain 1. So AC squared is equal to 1 plus 1, you're going to have 2. Then you find the square root of AC squared, also the other square root of 2. So you're going to find that your AC is equal to square root of 2. Remember, we are not using a calculator, so we are going to end from here. That means this side, the AC, is going to be square root of 2. From there now, we are going to introduce the three trigonometric ratios of sine, cosine, and a tangent. So if you have sine theta, we say sine theta is equal to opposite over hypotenuse. So what angles are we looking at? We are looking at the 45 degrees angle. So you are going to have sine 45 is equal to, what is opposite? If you stand here, you look at the opposite of this angle, it is this one, which is giving you what? 1. Divided by the hypotenuse is the longest distance, which is always opposite to the 90 degrees angle, which is the square root of 2. So that means in every triangle that you are going to find, sine 45 is 1 over square root of 2. What about the cos? Cos theta is equal to adjacent over hypotenuse. So cos 45, because that is the degrees that what we are looking at. What is the adjacent? The adjacent of this angle here, it is 1 over, what is the hypotenuse? Hypotenuse is the square root of 2. So anywhere where you go, you find it is 1 over 1 over the square root of 2. What about the tangent? Tan theta is equal to opposite over adjacent. So tan 45 is equal to opposite of this one, it is 1, divided by the adjacent also it is 1. So tan 45 is equal to 1 divided by 1, it is 1. So wherever you find tan 45, your answer should be 1. So let's also try to look at the other two angles, which is the 30 degrees and the 60 degrees. So let's look at the other two angles, which is 60 degrees and 30. So 30 degrees and 60 degrees triangle. So under this one, consider the equilateral triangle here. Equilateral triangle is the triangle that has got the same sides and the same angles. So if you have 60 here, even there is 60, even this side it is 60. That means if your distance here it is 2, that means also the other distance there it is 2, even here it is 2. That is what it means when we say equilateral triangle. It has got equal sides and equal triangles. So now we are saying under these special angles we are dealing with the 90 degrees triangle, which is a right angled triangle. So this means that we are going to cut this angle into two equal parts, which means we are going to bisect angle 60 here to come and meet line AB at what? At S. This means that here you are going to have a 90 degrees. Even the other side you are going to have a 90 degrees. So if you have from A to B it is 2. That means when you bisect this line into two equal parts, you are going to have one there and the other one that side. Also this side you are going to remain with 2 and this other side you are going to remain with 2. And if you bisect this angle, which is a 60 degrees angle, that means this side you are going to have what? 30 degrees. Also the other side here, 30 degrees. That means you have a triangle here which is going to look like this. 90 degrees. Here you are going to have 60 and here you are going to have 30. 2 this side and 1 this side. So what are you going to do for you to find CS? We are going to use the same formula of Pythagoras theorem. So remember, we are saying the Pythagoras theorem, we said the longest distance, which is CB squared, is equal to the shortest distance, the two short distance, which is CS squared plus SB squared. Then from there now we start fusing in whatever we have. So what is CB? CB is 2. So I'm going to have 2 squared is equal to. What is CS? CS is what we are looking for. CS squared. Plus, what is SB? SB, it is 1 squared. Okay. So what is 2 squared? 2 squared is 4. Is equal to CS squared plus 1 squared, it is 1. Then we collect the like terms together. The 1 will cross the equal sign to come and join 4 here, which is going to change the sign to negative. So we're going to have 4 minus 1 is equal to CS squared. Then what is 4 minus 1? 4 minus 1, it is 3 is equal to CS squared. Then you introduce the square root to the both sides so that you have CS is equal to. Okay, so from there now we are going to the 3 trigonometric ratios. We are going to start with the angle 30 here. So we are going to have Sine theta is equal to opposite over hypotenuse. So I think we are starting with the sine 30. So sine 30 is equal to, what is the opposite of sine 30? The opposite of it is 1. Over, what is its hypotenuse? Hypotenuse is 2. That means sine 30 is equal to 1 over 2. Then we go to cos. Cos theta is equal to adjacent over hypotenuse. So cos 30 is equal to, what is the adjacent? Adjacent is square root of 3 over the hypotenuse is 2. Then we go to tan. Tan theta is equal to opposite over adjacent. So tan 30 is equal to, what is the opposite? The opposite is 1 over, what is the adjacent? Adjacent is the square root of 3. From there now we will look at angle 60. These are the special angles for angle 30, sine, cosine, and the tangent. But we are going to look at angle 60. So sine 60 is equal to, so we are at this point, sine 60 is equal to opposite. What is opposite? Opposite is the square root of 3 over hypotenuse, which is 2. Then from there we go to what? To cos. Cos 60 is equal to adjacent, which is 1, over hypotenuse, which is 2. So cos 60 is equal to 1 over 2. Then lastly, tan 60 is equal to opposite, which is the square root of 3, over adjacent, which is 1. So square root of 3 divided by 1, we are going to have tan 60 is equal to square root of 3. So these are the 3 special angles, a 30 degrees, the 45 that we started with, and the 60 degrees angles. So having learned this, having looked at all these 3 trigonometric ratios, we are going to look at the 2017 paper 1 GCE. And remember, paper 1 we don't use a calculator, so that's why we are learning these special angles. The question reads, the diagram below shows a triangle ABC in which AC is equal to 18 centimeter, ABC is equal to 90 degrees, this is angle ABC, and angle CAB is equal to 30 degrees. This is the diagram which is shown. And they are saying calculate the length BC. So if you look at BC here, this is an opposite side. So what are we going to do? You are going to get a trigonometric ratio which has got what? Which has got opposite and the hypotenuse, because the hypotenuse has already been what? Given. And which sign are you going to use? It is the sine rule. So I'm going to say sine theta is equal to opposite over hypotenuse. So what is theta? Theta is what? It's 30. So sine 30 is equal to, what is opposite? Opposite is the one we are looking for, which is BC over, the hypotenuse is 18 centimeter. From there, if you look at this angle here, we said this angle it is opposite, which is 1, over hypotenuse, which is 2. So sine 30 is going to be replaced by 1 over 2. So we're going to have 1 over 2 is equal to BC over 18. Then from there you do what? you cross multiply. 2 times BC, you are going to have 2 BC is equal to 1 times 18, you are going to have 18. Then from there, you are going to divide both sides by 2. Both sides by 2, you are going to have BC is equal to 18 divided by 2, it is 9 centimeter. So you find that your BC is 9 centimeter. Thank you so much for watching this video. Look out for the next video that we are going to shoot very soon.